Okay, so once again, I welcome you all to my YouTube channel and thank you for coming back to see the lecture one. And lecture one, we will be discussing the basic concepts related to thermodynamics. And these basic concepts, basically, we are going to need it in the coming chapters. So before getting into details with these basic concepts, let us first try to understand the word thermodynamics itself. So, what is thermodynamics? And there are two aspects we can understand it by. So, one is using just by breaking the word, which is made up of two words from Greek, which is like two Greek words, thermi, which means heat, and then dynamis, which means power. And thermodynamics basically means how we can convert the heat to power. This is what thermodynamics is all about. Or we can also say how we are converting heat to work. And we will later see that to convert heat to work, we need a special kind of device, which we call heat engine. But it is not of our concern right now because we are just trying to define what is thermodynamics. And then there comes another perspective, and that we can understand using the energy perspective of thermodynamics. And by energy perspective, what I mean is thermodynamics can be defined as science of energy, and again, energy can be stored, energy can be transferred, or energy can be transformed. So, using the energy perspective, we can define thermodynamics as a science of energy, where energy storing, transferring, and transforming is being studied. Okay, and now the concept comes like, why do we need to understand thermodynamics? So, why? Why do we need to read thermodynamics at all? Why do we need to study thermodynamics at all? So, whatever you see, for example, take a look around yourself, or just take the example of your lungs, where certain mass and energy transfer is taking place. For example, you are breathing in air and then you are exhaling carbon dioxide, and then there is some heat transfer going on there. Take another example of air conditioning. So in air conditioning also, there are certain kind of mass and energy transfer, and that can be basically explained using principles of thermodynamics. Then we have airplanes, automobile engines, and how can we forget electricity? So electricity, which comes from power plants, they also work on the principles of thermodynamics. And to make all these systems, efficient, so that it can perform better, or to analyze these systems, we need principles of thermodynamics. Principles of thermodynamics. And that's why we need to study it. Okay. Now, once we are convinced, and I hope you are also convinced that, okay, we need principles of thermodynamics or we need to study thermodynamics to better design these systems. So if you are already convinced, then we can go on further in our lecture to check how can we study these systems. So how to proceed? For example, if you want to study an air conditioning device or heat engine or a jet engine, whatever. So to study all these kind of devices, we need to define a term which you will be hearing, which you will be hearing in the upcoming lectures, like a lot of times. And that term is called system. And you might be knowing about this. So it is not like a government system or any other system. It is like in thermodynamics, we say that a system can be defined as whatever we want to study. Yeah, we want to study whatever we want to study or whatever is of our concern, that we can call it a system. We're not convinced, right? That what is a system. So we need a more technical approach. It is not like, yeah, it is like whenever somebody asks what is a system, you say that whatever you want to study, and then they can say that, what do you mean? Then to give it more technical perspective, we can say that, okay, it can be a fixed quantity of matter or a region of a space. Now these terms are very carefully written because you will see after some time that a fixed quantity of matter, we will call it further as, we will define it as closed system, and then you will also see, and I will explain it, that a region of a space, we call it like open system. So what is a fixed quantity of matter? So for example, you can take a piston cylinder arrangement. Here is my piston cylinder arrangement. Suppose we have certain amount of gas in it. Then we can call this gas, which is inside this boundary. And if you are marking my words, then I have used a term boundary here, which separates the system to surroundings. So suppose if you are considering this region, which has a fixed mass, and you call it as system, then I can put a dotted line around this, which encloses this mass, and I can call this as boundary, and whatever is outside, I will call it as surroundings. Okay. So this is an example of a closed system, and the example of lungs, where I told you that, okay, suppose if you have, yeah, I'm not good at drawing, so Let us avoid drawing the lungs. Or suppose there is a automobile engine where some air plus fuel is entering, then some exhaust gases are leaving, then there is also some energy transfer like heat, energy transfer like work. So these things are going on here, and we call this kind of system as open system. And we define a system boundary here as something like this. And there are more aspects to the closed and open systems. And if we try to list all the characteristics of closed and open and closed system, then we can say it like related to mass transfer and energy transfer. Okay. Mass transfer and energy transfer. Then like this. Open system, closed system. So open system, mass transfer is allowed, energy transfer is also allowed. In closed system, mass transfer is not allowed, but energy transfer is allowed. And suppose, and there is a special case of closed system, where mass transfer is not allowed, as well as energy transfer is also not allowed. And this kind of system is called as isolated systems. Okay. Having known this open and closed system, now the next step comes is how to describe a system. And to describe a system, we generally take two approaches. One is macroscopic approach, where we are mostly concerned about the overall behavior of the system. For example, you can say that gas is at a certain pressure, gas is at a certain temperature, and we are not concerned about what is happening at the molecular level. So we are just considering the overall behavior. We are considering the overall behavior or overall characteristic of the system, and that we call as macroscopic approach. And the thermodynamics, which considers this macroscopic approach for the study, we say it as like classical thermodynamics. Classical thermodynamics. Now, there are other approaches. For example, how will we call it when the particular or at molecular level, if we are considering the system at molecular level, we are also considering the characteristics at molecular level, then we call it as microscopic approach. Okay. Here we are concerned about particle level or molecular level behavior also. Molecular level behavior. Okay. And this we call a macroscopic approach. And here the study of thermodynamics, which basically considers this molecular level behavior, we call it as statistical thermodynamics. And one thing to note is our concern here is in this course we are basically considering classical thermodynamics. Classical thermodynamics is our focus here. Okay. So in this course, we will be discussing about this macroscopic approach, and we just saw that we call it classical thermodynamics. So this is going to be our approach for this whole lecture. Now we know that, okay, we are going to consider this macroscopic behavior or the overall behavior of our systems. To define this macroscopic behavior, macroscopic view of thermodynamics, we need certain other quantities, which is called, so one of such quantity is property. Now we need to define what is property. So property is basically a characteristic of the system. Property is basically characteristic of a system, or we can also say that property is a macroscopic characteristic of a system. To be more precise, microscopic characteristic of a system to which a numerical value can be assigned. And this term here is very important. This term numerical value can be assigned is very, very important, because that is how we define the property. And what are the examples? So examples are, you already know, volume, temperature, pressure, etc. Now this property, they can be further divided in, or they can be further classified into two categories. So this property, they can be classified it into like two. One is extensive property, which depends on size. For example, volume, mass, and then there is other class which is called intensive property, which is independent of size. And the example is density, or whatever the extensive properties. If you divide the extensive properties by mass, so I say extensive, suppose if you have some extensive property and if you divide it with mass, then it becomes intensive property, because now your extensive property per unit mass is actually independent of mass. So you can call it as intensive properties. Now, once you have defined the system, once you have defined the properties, then there is another term which we need to define, that is called state of the system. Suppose we will again take the example of the piston cylinder. So if this is our piston and there is some gas in this which is at temperature T, pressure P, so we can call this gas at some state which is defined by these properties. So this state basically refers to the condition of the system as described by its properties. Okay. And and if no properties are changing with time, then we can call it as steady state. Okay. Then we will call it as steady state. Okay. Now there comes another thing. So suppose earlier this gas in this piston cylinder was at state 1, and by something, for example, adding heat, the system has now different set of properties, like different temperature and different pressure. It has gone to state 2. So from state 1 to state 2, whatever you did, like adding this heat, we can call this as process. So here basically we learned 3 things. What are those? First is property, then state, and then process. Okay. So state is defined by properties, and then change in a state is given by process. Okay. And now we need to discuss a very important term, which we all know from our mechanics class, but you will see that in thermodynamics, this has a completely different meaning. So call it equilibrium. So in mechanics class, we know that equilibrium means just the balance of forces. But in thermodynamics, equilibrium means way more than that, which is like mechanical equilibrium, thermal equilibrium, chemical equilibrium, so mechanical means no unbalanced forces or pressure. Thermal means no temperature difference or no heat transfer kind of. And then chemical means no chemical reactions. And if a system displays all the characteristics of mechanical, thermal, and chemical equilibrium, then we can say that it is in equilibrium state or thermodynamic equilibrium. Okay. Also, to study thermodynamics, we need to have a basic concept like units, dimensions. So from our high school physics classes, we know that, okay, we have units of length as meter. Now you know that, okay, so meter is here the unit and the length is dimension. Okay, then units of mass is kg. So this is unit, and then mass is dimension. And then if we talk about dimensions, so we have like mass, length, time, and temperature. So these are 4 dimensions, and the units and the corresponding units are kg, meter, second, and theta, Kelvin, degree Celsius, not theta, sorry, not theta. Theta we generally use to represent this. So mass, we generally represent it with square bracket and then block letter M, then L, E, and then this thing as theta. So suppose if I am asking you to give me the dimensions of velocity, so dimension can be given as L over T in the square bracket, and the units can be given as meter per second. So this is dimension, this is unit. Okay, and with this, let us finish this first part of the lecture here, and in next lecture, we will discuss some properties in detail, and they are a specific volume, pressure, and temperature. These properties need to be studied in detail to understand thermodynamics, and we will thank you once again for joining the lecture series, and I will be waiting for you to also come and watch the next lecture on these 3 topics. Okay, thank you.